Climate change is a massive issue, with the last 5 years being the hottest on record. Renewable energies, like wind and solar, help us wean off fossil fuels to combat climate change. While we've made progress with these, we need another reliable and economical renewable energy source. Ocean waves hold a massive amount of renewable energy. Just 4 feet of wavefront carries enough power for 32 homes. The problem is, we haven't yet found a cheap way to harness that energy. Through expansive and iterative research, I found a way to capture wave energy economically. I'm proud to present the Navitas Sea Serpent. The 2-meter device uses 2 well-studied mechanisms to capture wave energy and deliver it to the shore. The mechanisms, a turbine and its linkage, elegantly work together to capture both the lateral and vertical movements of the wave, minimizing downtime. The helical turbine is powered from any direction, turning the back and forth of the wave into continuous rotation. The linkage pulls cables as the turbine and a chain moves relative to each other. The cables pull on the turbine, working together out of phase to power the same generator. Due to the length of one of these serpent chains, the drag forces start to cancel out as pulling on one end is matched with pushing on the other. This means the turbines don't have to be rigidly attached to the seabed, and installation is as cheap and easy as dropping an anchor. There's also ease with modularity, making Navitas scalable and maintenance simpler. So how do we know it works? I coded a MATLAB simulation using real numbers, drag, buoyancy, and turbine properties from literature. The simulation showed the chain of 5 turbines lagging behind each other as they bob up and down in the wave. For a range of practical wave frequencies, the 2 stages remain relatively compatible. The results: using Pacific waves, Navitas generated 7.4 kilowatts per turbine. Using off-the-shelf parts and machining estimates, I estimate the price for a turbine to be around $8,800. This makes Navitas economical compared with renewables and even fossil fuels. Smaller scale, easy to install, and a turbine deemed relatively safe for wildlife, Navitas is a perfect option for coastal communities, many already feeling the impacts of climate change. A system in Chile could provide 400 megawatt hours of clean energy a year, power for just $670 a person, not just for a year, but over the entire lifetime of the device. Building on the learnings of past projects, Navitas reinvents how we see the ocean and treat the Earth, economically and sustainably.